Hi there. So in one of our previous videos, when we first started using trigonometry, we used trigonometry to find unknown sides. And now what we'll do in this video is use trigonometry to find unknown angles. Now I will tell you there's several pieces to this story. It actually ends up being pretty straightforward to do, but there's just a little piece of information that I need to provide along the way. The first part's going to seem a little bit out of context with all of this. It's going to have to do with the reciprocal functions. Okay, so yeah, we need to talk about computing the reciprocal functions on a calculator. We won't really have to do this a whole lot from the way I teach it. I mostly focus on just using the sine, cosine, and tangent. But you will see cases probably where you have something like this and you need to compute it. Okay, now, and also remember, if you're forgetting, let me just make this a little side note here. So as far as what the reciprocal functions are, that's the secant, the secant, the cosecant, and the cotangent. So that's what I'm talking about. All right, and hopefully you're starting to get the definitions down where you know which basic trig function those are the reciprocal of. Okay, and so the key thing here is if I wanted to do the secant of 49 degrees, this is the reciprocal. Which basic trig function is secant the reciprocal of? It's the reciprocal of the cosine. Okay, like that. Now, so the key thing is whenever you look at your calculator, there's a common, this is the reason I'm bringing this all up, there's a common mistake that people make. Right above the cosine key as a second feature, you're going to see this thing right here. Okay, so you might think that you're going to use this key on your calculator to do the reciprocal of the cosine, and that's the main thing to get out of your brain right now is that is not the reciprocal, and I'll explain that later. That's actually a function that we're going to use to find angles, okay, like that. So the other thing is mathematically, you know, whenever we see a fraction, and if I were to ask you what its reciprocal is, okay, then a lot of us know we just flip that fraction over. Okay, but with computers and calculators, which is what we're trying to use to get this right here, with computers and calculators, you can't tell a computer just to flip something over. It doesn't know what that means. It doesn't have a thinking brain like we do. Okay, they have to be programmed. Okay, and so mathematically, if you have a number x and you want to give an equation for its reciprocal, the way to do that mathematically is to say 1 over x. All right, like that. All right, and just to explain how this works, if I started with 2/3 and I wanted it to compute its reciprocal using this formula, I would say 1 over 2/3. And just remember right here, this means divide, and so I'm dividing 1 divided by 2/3. That's dividing fractions, and so I would multiply times the reciprocal 3/2, and so that comes out to be 3/2, which is what I would expect. So all I'm doing right here is showing you that this formula actually works. It gives you the answer that we expect to see just by looking at it. Okay, and so now let's go back to the secant of 49 degrees. The secant of 49 degrees, like that, is I said is, remember the way we can write is mathematically is with an equal sign, and so it's equal to the reciprocal of the cosine of 49 degrees, like that. Well, but then what does this say? A number has reciprocal 1 over that number, all right? And so that would be 1 divided by, or 1 over the cosine of 49 degrees. All right, so that's actually how you compute the reciprocal functions on your calculator. You do 1 over. So just as another example, say I had the cotangent of 65 degrees. Okay, the cotangent is reciprocal to the tangent, so I would type in on my calculator 1 divided by the tangent of 65 degrees. Okay, like that. So we don't ever use these keys right here. This is actually notation that I'm going to explain in a moment, but we don't use these keys to do the reciprocal functions. These are called the inverse trig functions. Now, so what we're ready to do is we're ready to talk about finding an angle given that we have a right triangle. That's very important. And now we're going to be given two sides. So remember, whenever we found sides, we were given another angle and another side. Now we're going to be given two sides, at least two sides. Okay, so let's look at this with an example, and I'll try to be brief, and then I can explain some of the theory if you'd like to. Okay, and so here's a right triangle, and so now say I'm given two sides. So say this side right here is 2, and this side right here is 5, and then I have this angle right here, theta, and the idea is to be able to find theta. Okay, like that. All right, and so it pretty much follows the same format as whenever we were trying to find sides. First of all, make sure you have a right angle, a right triangle before you do this, but we do. Okay, and so the idea here is first to label the sides, you know, in terms of our triangle labeling. So in terms of hypotenuse, opposite, and the adjacent. Okay, like that. And so if we come over here, remember the hypotenuse is always opposite the right angle, so the 5 is the hypotenuse here. All right, and then to get the other labels, we got to look at what angle we're talking about. Here's our angle theta, and so 2 is the opposite, and then so this third side would be the adjacent. Okay, and then identify what you're given in terms of labels. Oops, I can't spell labels. I did that yesterday too. Okay, so in terms of the labels, all right, and so notice what we're given here. We're given the hypotenuse and the opposite. Okay, like that, and so then just identify the trig function that relates them. Okay, so we were given the hypotenuse and the opposite, and so that's the sine function, like that. Okay, and so then what we want to do is we want to write the definition and fill in numbers. Okay, like that. And so the definition is that the sine of theta is equal to the opposite over the hypotenuse. All right, now theta is not known here, so I would just write sine. Now if the name of your angle were something different, like if this were alpha, then I'd want to change this theta to an alpha. But we called this first example theta, so we just say sine theta is 2/5. Okay, now the key thing is we need to solve for theta. We want to get theta all by itself. All right, so try to think about different ways you can do that, and we'll discuss it on the next slide. Okay, so we started here in this situation, and then that led to this equation, sine theta equals 2/5. And the idea is that we want to solve for theta, right? Like that. And I'll be kind of brief with this explanation, but there's some things that need to be pointed out. Okay, first of all, remember what it means to solve for theta is that you want to isolate theta. And so, i.e., we want to do some work here and then end up having theta equal something. So theta would be all by itself. All right. So one thing here to point out is people will often say, well, then you would just divide by sine. Okay. But it doesn't make any sense to write a trig function all by itself. We can make a little joke out of having a sine. That would be a sin to write sine all by itself. All right, and the way you can kind of see how that's kind of silly to do is imagine having this equation. Square root of x is equal to 4. Okay, we don't solve that equation by dividing by the square root. That doesn't make any sense. It doesn't make any sense to write the square root of all by itself. You have to take the square root of something. All right, same thing with the sine. The sine is a function. You have to take the sine of something. So it never makes any sense to write sine all by itself. Same thing with cosine and tangent. Okay, and so that's not the what we want to do here. And let's come back to this example here too. Some of you know how to solve this equation. What would you do to solve this equation? All right, and that is that you would square both sides. And the reason for that is, I'm not going to write all this out, but the reason for that is that a square cancels a square root. So these things are called inverse functions. The square is its own function, the square root is its own function, and these are two functions that cancel each other, and that's what we call inverses. That gets a little bit lost in algebra class because we try to talk more generally about inverses, but that's the whole idea about function inverses, is they're just a pair of functions that cancel each other. If you remember from your algebra class doing exponentials, we use logarithms to cancel exponentials, and so logarithms and exponentials are inverse pairs of each other. Okay, so that's what we need here. Okay, so let me erase this because that's a no-no. All right, so to get theta all by itself, all right, this is all side information here. So to get theta all by itself, we need the inverse of the sine. Okay, and this is where those buttons that I was talking about a minute ago, the inverse to the sine is denoted like this. Okay, so this is just notation. Make sure you realize this is not an exponent. Okay, this is just notation for the inverse sine function. Okay, and because of that confusion, some people actually call this the arc sine. So every once in a while in your reading, you might see someone refer to arc sine. These are the same things, but I'm mostly going to focus on this notation because this is the notation on your calculator. Okay, and so the inverse, and we call this the inverse sine function, or some people say sine inverse. Okay, and what I'm getting at here is that's what we need to do. We need to take inverse sine of both sides of the equation. All right, so let's go back to our equation so you can see this. So we have sine of theta is equal to 2/5. Okay, and so now you'll get used to this where you won't need this line, but we're going to take the inverse sine of both sides. And because the inverse sine is a function, we always want to write it on the left. Okay, because we're taking the inverse sine of 2/5. Okay, it doesn't make any sense to write this, is what I'm getting at. Okay, it's like this writing inverse sine all by itself is like writing the sine by itself. It just doesn't make sense mathematically. Okay, and so so we have that, and here's the key thing about this: the inverse sine cancels the sine, and so on my left I have theta, which is what I was looking for, and on my right I have the inverse sine of 2/5, like that. All right, now that's the exact answer for theta. Okay, like that. And so let me show you how to get the approximate. You can probably guess how to get the approximate. I usually, whenever we're finding angles, have students give the angles in DMS whenever we're finding degree angles. So I also want to show you how we get to DMS easily. Okay, so here I am on my TI calculator. All the TI calculators have the same kind of feature. So if you're using a calculator and you can't find how to get it into DMS after I show you, let me know and we can figure out how your calculator works. Okay, but the general idea here is that our angle is the inverse sine of 2/5. Sorry, I just had to remind myself that's what it was. So I come here and I hit the inverse sine key, all right, and then I type 2/5, like that. All right, so there's my angle in decimal degrees. My angle's about 23.578 degrees. All right, and if you want that in DMS, what you can do here, there's a quick feature on your calculator that allows you to do DMS. It's right here. It says it's under this menu called angle. All right, and so you need to hit the second key and then this key. And see, notice right here at number 4, it says 2D, but that arrow means 2. So it's saying 2 DMS. So I would just press 4, since it's on option 4, like that. And then notice that it gives me that angle in DMS, okay? Like that. The other way you can do it too, you can do this all in one line. If you know you're going to want the DMS, you can just do inverse sine of 2/5. You can do it the way I just did. It's 2 lines. It's no big deal. Or if you understand and want to be a little faster about it, you can just say compute that number and convert it to DMS, and then it'll just spit out the DMS for us. So there is our angle in DMS. All right, and remembering that I usually round to the nearest whole number seconds, so I'm going to round the last part of that. So this is approximately equal to 23 degrees, 34 minutes, and 41 seconds, like that. And so that's usually how I would answer that question. Now, one thing before we move on too, we're about to start combining a lot of things, and some problems we'll be finding angles, some problems we'll be finding lengths, and some problems we'll be finding angles and lengths. It's really important not to overuse that DMS key. Okay, that's only whenever we're finding an angle do we give that angle in DMS. So I've had students in a problem where they're trying to find a side length. They'll go and get the exact answer for X, and then they'll end up writing that in DMS. Okay, and that doesn't make any sense. DMS only has to do with angles, not side lengths. All right, and so I just want to make sure you have this process down. So here's 3 examples. I would advise pausing and trying and making sure you can get these. And I'm going to pause for a second, but then I'm going to carry on. But like I would advise pausing and making sure you get the process down. Okay, anyway, so in problem 1, we have this right triangle here, and so we need to label our sides. Here's the right angle, so that side's going to be the hypotenuse, all right? And then in terms of our angle, we have this angle theta. 3 is its opposite side, and so the third side would be the adjacent side, like that. And so what are we given? We're given the opposite and the adjacent side. Which trig function replaces the opposite and the adjacent? That would be the tangent. Okay, so we write the definition. Tan theta is equal to opposite over adjacent, like that. And then tan, our angle's named theta, so we would still use theta. And then my opposite side is 3 and my adjacent side is 7. All right, and so now I need to cancel the tangent. So how would I cancel the tangent? I would take the inverse tangent of both sides. All right, and this one I'll go ahead and write out explicitly. So we just take the inverse tangent of both sides, like that. And so again, the inverse tangent and the tangent cancel each other. So I get theta is equal to the inverse tangent of 3/7. That's my exact answer. See if you can get that in DMS. Hopefully you paused and you already have a guess of it in DMS. But if not, then you just have it convert to DMS, and we get 23 degrees, 11 minutes. Strange, that's almost the same answer as last time, huh? Now be careful of the seconds. I rounded the nearest whole number seconds, so it's 54.9. So I'd want to say 55 seconds, like that. And there's the answer to the first problem. All right, so now for problem 2, we need to get our labels here. So here's my right angle. The side opposite it is the 15. So there's my hypotenuse. And then here's my angle, alpha. Here's its opposite side. It's unnamed. And so this would be the adjacent side. Okay, and so what are we given? We're given the adjacent and the hypotenuse. Which trig function relates adjacent and hypotenuse? The cosine, like that. So I write its definition. Cosine of theta equals the adjacent over the hypotenuse, like that. Now this one's a little bit strange because in the definition we usually write theta, but now my angle is named alpha, so I want to change that to alpha. And then my adjacent side is 2, and my hypotenuse is 15. Okay, so I would take the inverse cosine of both sides. All right, like that. And here they cancel, so I just get alpha, and here I get the inverse cosine of 2/15, like that. All right, that's the exact answer. And so now I go and plug it in, inverse cosine of 2/15, and I usually save myself a little bit of time and go ahead and just type, tell the calculator to convert it to DMS before I even see the decimal form. So that would be about 82 degrees. 20 minutes. Make sure you realize those seconds round, so we get 16 seconds. All right, and so there's that angle. All right, one last one here. And so problem 3, we need to label the sides. And so here's my right angle, that's the hypotenuse. That here's my angle, here's my given angle, my specified angle, and 4 is opposite it, so 4 is the opposite side, and so 5 is the adjacent. All right, so what sides are we given? We're given the adjacent and the opposite. Which trig function deals with adjacent and opposite? That would be the tangent again. All right, and so in terms of the definition, it's tangent of theta equals opposite over adjacent. I go and fill things in. My angle's named beta, so I have tangent of beta is equal to, and then the opposite is 4, and the adjacent is 5. All right, then to isolate beta, we take the inverse tangent of both sides, and so I end up with beta is equal to the inverse tangent of 4/5. And then if I want the approximation to that, I just type in inverse tangent 4/5, and then I tell the calculator to convert it to DMS, and I get 38 degrees, 39 minutes, and 35 seconds. Okay, so hopefully that makes sense about the basic uses of the inverse trig functions. I will tell you later, we'll talk about inverse trig functions again in more detail whenever we're doing analytic geometry. There's a lot more to them, but as long as we're just solving triangles, working with triangles, then they're pretty basic. The key thing is, too, that these inverse trig functions, what are we using them for? We're using them to find angles. Now, if you think about it, whether you start out finding a side or if you start out finding an angle, once you found that piece of information, you can actually figure out everything else about that triangle. And I'll outline that to you in just a moment. But and that leads into kind of a general kind of instruction. And like I mentioned earlier, sometimes whenever you're doing a geometry problem with trigonometry, you're just interested in one thing. So you focus on things like we were just doing. Other times you want to know everything you can about that picture or that triangle. And that leads into this idea of what's called solving a triangle, or you'll see the instructions, solve the triangle. And what that means is to find all angles and all sides. Okay, so let's just look back at that one we just finished off with, number 3. Okay, so this was the problem that we started with, but say I wanted to solve this triangle instead. Now, we already got that beta is equal to the inverse tangent of 4/5. So notice that we know this right angle, and now we know beta, and so we could label it. Let's just label this angle right here something else. Let's just use good old theta there. Okay, how could we find theta? Well, if you remember, the angles in a triangle add up to 180 degrees. So to find theta, we know that we have 90 degrees, and then we have beta, but we know that. That's key to remember. It's not an unknown. And then we have theta, and that would equal 180 degrees. Now, first of all, let me show you a slight shortcut. We're going to solve this for theta, but notice if I subtract 90 degrees first, like that, I get that beta plus theta is equal to 90 degrees. Okay, so it's just it's not really at the crux, but it's a nice little shortcut if you haven't realized it. Whenever you're dealing with right angles, the other two angles have to add up to 90 degrees. We've mentioned that before. The other two angles are complementary. Okay, so anyway, so to get theta now, I could subtract beta from both sides. Remember that we know what it is. And so we have theta is equal to 90 degrees minus beta, but what is beta? It's the inverse tangent of 4/5, like that. So we could type that in on our calculator, and 90 minus the inverse tangent of 4/5, and then tell the calculator to convert that to DMS, like that, and we get approximately 51 degrees, 20 seconds. Notice that the minutes, I'm sorry, 20 minutes, and notice that the seconds round up to 25 seconds, like that. Okay, so there's another piece of the answer. Okay, now we haven't solved the triangle yet. What's missing? Now we know all three angles, but we don't know this base side right here. So let's give that a name, x, like that. All right, and so if we have that base side of x, what's different ways we could find x? There's a few ways. There's a few ways. First, since we know two sides of the right triangle, we could use the Pythagorean theorem. Okay, and so for the Pythagorean theorem, x is the hypotenuse. So we have 5 squared plus 4 squared is equal to x squared. So we have 25 plus 16 is equal to x squared. And that would be 41 is equal to x squared. We're going to take the square root of that though. So we get x is the square root of 41. And the square root of 41 is approximately equal to 6.40. Okay, make sure you realize the units for angles, at least for now, are degrees or degrees, minutes, and seconds. But x is a side length, so we would not convert that to DMS. Let's go back to our problem and put some units on here. So say this, everything's measured in feet on the sides, then we would want to say that x is in feet. Okay, now whenever you have these problems that have several answers in them, it's just good advice. I actually picked this up from students doing it, and it helps you and helps the teacher too. So, it's good to just write a little answer box here whenever you go through all of that. So, beta was about 38 degrees, 39 minutes, and 35 seconds. And then theta is about 51 degrees, 20 seconds, and 20 minutes and 25 seconds. And then x is the square root of 41, which is about equal to 6.40 feet. Okay, now one thing too, I mentioned in a previous video, I like to use the Pythagorean theorem to check. So what you could do instead, you could use trig to find x. Okay, and so you just pick an angle, beta or theta, to solve for x. And so let's use beta. Okay, and so if we used beta, x is the hypotenuse. And you can pick either of the other sides, and either of the other given sides. So let's just use the 4 is the opposite. So that would be the sine, like that. And since I'm running out of room, I'm just going to abbreviate it. That would give you the equation that the sine of beta is equal to 4 over x. And then you go through your proportions to solve. You'll end up getting x is equal to 4 over the sine of beta. Now, I've showed you how to use the store key before, but if you didn't happen to think to save that beta, you can just type in its exact form. It's a little bit complicated, but it would be 4 divided by the sine. Beta is the inverse tangent of 4/5. That. And you can type all that in. Just type it in just like you have it written. So you type 4 divided by, and then sine of the inverse tangent of 4 over 5, and then you need 2 closing parentheses, like that, and that still gives you the 6.40 that we saw using Pythagorean theorem. Okay, so that's about it with finding angles. We can use this technique to find all types of angles with all kinds of shapes, not just triangles. But I'm just trying to keep the video kind of brief, and so I hope that helps, and I wish you the best.